All right, so can we get the CDF, please? Let's quit with this nonsense here and get the CDF. Get the CDF. Get the CDF. That is the probability that W is less than or equal to any number, say little w. Now I know what it is for this, right? The chance that W is less than or equal to 0 is going to be a quarter, right? And also the chance that W is less or equal to, say, any number x is going to be 0 for x strictly less than 0, right? I know that too. There's sort of a jump there at 0, right? First of all, this just says you can't, the chance of using a negative amount of water is 0. And this says that the chance, then these two combined says that the chance that these two things together come together to imply that the probability of W equaling 0 exactly, well, that's the chance that W is less or equal to 0 minus the chance that W is strictly less than 0, which is a quarter minus 0, which is a quarter, I guess, right? Okay, but now what about for some amount of water between 0 and 1,000 gallons? What about for some amount of water between 0 and 1,000 gallons? So say W in 0 to 1,000. I have that conditional density function, right? What I want is the non-conditional CDF. I want this, right? Chance that W is less than or equal to little w. I know it's going to be at least a quarter, right? Because there's that jump there of size 1/4 at 0. And now I want to add to it this integral. I sort of need to integrate this density function in a sense, right? So what's the density function that I need to integrate there? Well, it looks a lot like the one that I got. 2 over a million. And then times, we have there W, dW from 0 to W. But there's one subtle little thing there, okay? The chance of it being exactly 0 is a quarter. So that means the chance of of having some amount of water that's at least 0 and less or equal to 1,000 is actually 75%. So what I want to do is keep this same shape for the density function, but scale it down by 3/4. Scale it down 75%, or to 75% of its original height there. I'm just going to multiply that by 75%. How do you like them apples? Okay, so if I work this out, then this is, oh, you know what? This is really stupid. I should use another variable there. Sorry about that. This should be a function of little w there. This just looks better if I do it like that. So this is going to be a quarter, right? Plus, I guess this works out to be 1.5 over a million. And then times, what is this, x squared over 2, I guess, from 0 to w. The 2 and the 1.5 cancel, of course, to make 3/4, 3 over 4 million, right? Do it like that. And then, so this is a quarter plus, it's just 3 w squared over 4 million. Okay, so note that things seem to check out, right? If I put in a 0 for W here, then all this is 0 and I get a quarter. So that the chance that the amount of water is less than or equal to 0 is still a quarter. Also, if I put in, let's see, what's the most amount of money, the most amount of water I can have? It's 1,000 gallons, right? So if I put 1,000 in here for W, I get, let's see, 1,000 squared is 1,000,000, and then 1,000,000 times 3 is 3,000,000. 3,000,000 over 4,000,000 is 75%. 75% plus a quarter is 1. Okay, so things are checking out okay. And then finally, also, we have to be complete here. The probability that W is less than or equal to little w should be 1 for any W greater than 1,000. Okay, so now let's write down the CDF nice and neatly and completely then. It's F sub W of W is, well, let's see, it's going to be 0 for W less than 0, or it'll be a quarter for W equal to 0, or it'll be a quarter plus 3 over 4,000,000 times W squared for W in the half-open interval from 0 to 1,000. Or finally, it'll be 1 for W greater than 1,000. Okay, let's graph this guy. Okay, it's 0 down here, so you get to 0, and then suddenly jumps up to a quarter, right? It's 0. Here's 1,000, and these are in units of gallons, right? Okay, this is a parabola, right? This is a parabola. Looks something like this, I think. Yeah, something like that. And then it just flattens out. It goes on like that. Forever. Okay. Good. Now, hey, what are we interested in here? I don't know. Maybe we're interested in well, you can certainly get the chance that you can certainly use this to get the chance that you use a certain amount of water or less than a certain amount of water or whatever. You might also be interested in knowing the expected value of the amount of water. By the way, the expected value for a random variable more generally now could be written using these Stieltjes integrals. If they're mixed like this and they have points of jump, you could just integrate x with respect to f sub x of dx. Okay, where again these weights are, if there's a discrete part, this just picks up a non-zero amount. This is no longer just a density function times dx. All this stuff could be strictly greater than 0. If there's a discrete part, then this is just the size of the jump. This is just the size of the jump. Okay. Also, if g is some function, if it's some real valued function, then you might be interested in, if g was a cost function, for example. You might be interested in the cost for the expected cost for the amount of water you use, and this might look like this: g of little x times df sub x of x. Okay.